AI is giving cameras superpowers in low light conditions. G'day. One of the problems we've all witnessed when using cameras is their ability to take pictures in the dark. We might be outside or at a party, the lighting is fine for us, our eyes have adjusted, and we take a picture and either the image is really dark or it's full of noise and all the colors are completely corrupted or washed out. This problem isn't just for us taking our personal photos, but it's actually a problem in the AI world as well, because the machine learning models can't distinguish the classes or the objects that it sees in the image. So for applications like self-driving or for detecting insecurity applications, the AI can't actually see the objects that it needs to pick up and detect. In the outdoor natural environment, roughly half of the time it's dark. It's essentially too dark to use regular cameras. And even in urban environments that are generally lit, there are still many areas that do not have very good lighting. And internally, inside, you really have to turn the light switch on in order to have good imaging. There are many situations where we want to get good imagery and we can't because of the capabilities of the cameras. Now, the human eye has fairly good night vision performance. This is because it has two mechanisms in the eye. One is called the cones, which is good for color and fine acuity, and the rods, which are off axis. And if you want to see what this looks like, just go outside in a dark environment and let your eyes adjust and then stare ahead, and then you'll see things to the left and to the right of you, but when you actually turn to look at them, you'll find that you actually can't see them as well as if you look slightly off axis. And this is because these rods are able to work. Now, the rods don't have color detection, but they're very good for detecting movement. So as we've evolved to avoid predation, having good off-axis vision to detect movement and things like that can really help protect us. But as we're evolved from primates, we predominantly don't do a lot of our activity at night. Now, there are many other animals out there in the animal kingdom that have much better vision. For example, the big cats have excellent night vision and they can see us even if we couldn't see them. So their eyes are evolved much better to see in the dark. Now, the unit of light measurement is the lux, and 1 lux is basically equivalent to a candle held at a distance of 1 meter, and the amount of light that hits your eyes is 1 lux. And we can see reasonably well in 1 lux. But by comparison, a typical room is usually lit with about 300 to 500 lux. If you go outside on a cloudy day, it's around that 3,000 and even up to 100,000 lux in a really bright sunny day. But down at the lower end of the light performance is where it gets kind of tricky. But let's see what it is actually in this room. I have a thing called a lux meter here, and if I hold that up, there you can see that it's around about 79 lux, or between 79 and 81 lux in this room. So this room isn't particularly well lit, and that's because I need it slightly darker for the background lighting to look good. If you are outside in a natural environment, then things like the moon and the stars are the main forms of light once the sun is down. A full moon night with no clouds, maybe as much as 1 lux. When the moon is at a crescent phase, it may be 0.1 lux. And if there's no moon at all on a clear night, it may be 0.001 lux, so very low light. And if you've experienced these situations, you see it's very hard to move around at night in starlight. But as the moon comes on, you can actually pretty much navigate yourself quite well. So you can tell, what sort of performance your eye is really just through experience. Of course, you have to get away from all the urban lighting and other things to really experience this. When it comes to cameras, there are a few technologies we'll briefly discuss. And we need to understand the sort of trade-offs that are always made whenever we choose technologies. So in history, there were things called film cameras, and they were really a chemical deposit on top of a plastic film, and these were grains of chemical that reacted to light. And generally you would buy film with grain sizes depending on the low light performance that you required. And the larger the grain size, the better low light performance, but of course the larger the grain size, the lower the resolution. So the very clear trade-off was made there in film cameras. Of course we don't use film so much anymore, except in specialist applications, but the consumer generally is using digital cameras, such as in your cell phone or in a dedicated camera. And there's two main technologies to discuss here. There's charge coupled devices, or CCDs as they were called, and these are more commonly used in security applications, and they've really swung out of favor because although traditionally they had great image quality performance and great low light performance, the second and emerging technology has really surpassed that, and that is the CMOS camera. CMOS is a silicon-based technology, and it's something that has matured so much over the last 20 years that it's really displaced CCDs in most low-cost and consumer applications. Now, CMOS technology had the worst noise performance of all the technologies. That was 20 years ago, and when we were experimenting with those cameras, we were starting to lose image quality anything below 10 lux. There would be noise artifacts, you'd lose the color. The noise artifacts weren't just the random noise, but also column and row noise would start to appear. Now, two things have happened over that last 20 years. The fundamental pixels have improved, that lowers the noise performance, and secondly, the resolution has improved enormously. So these two things go together to help improve image quality. The first fundamental one, well, you're just going to get better performance and less noise each pixel, but as you scale up the imager for higher resolution, all of those noise artifacts become relatively smaller, so less noticeable. So you get a natural image quality improvement as you go up in resolution. Now, the image sensor is of course just part of the whole camera system and what generates image quality or observability of objects in the scene. But there's other factors, of course. There's the optics. It hasn't really changed a lot in the last 20 years or even longer. You are kind of stuck with what technology exists, and I don't see that changing. And then there's the image pipeline, or the processing of data that comes out of the sensor. And this has certainly improved marginally and made improvements in terms of improving image quality and observability of the scene. But the new thing, and that's the exciting thing that's happening right now, is the introduction of AI, machine learning techniques, which have revolutionized image quality and observability in CMOS and other image sensors. There are multiple companies, and I'll leave some links in the description, that are working on the most exciting and interesting aspect of image quality and detection, and that is to tap into what the human vision system does, and that's using their neural networking processing. As humans, we have a very large part of our brain dedicated to the vision system and using the information that's coming in to render into objects and things that we see, and we understand the world around us. And it's this that these companies are starting to tap into. And the way they have been doing this, or the way they're doing it now, is to actually take the raw data out of the image sensor and put that straight into a neural network processor, an NPU or a GPU operating as a neural network. In the similar way to the human vision system, this is taking those images straight from the eye, pushing it through a vision system, then out into the real world. And this has had some incredible performance improvements. The result of this has been an improvement in image quality and the ability to detect in AI systems. So one way to see that is to have a look at a high dynamic range image, and you can see the details in the dark that you wouldn't be able to see before. Another way to see this is to actually take an image in a low light environment. So without this technology, perhaps 1 lux outside, equivalent to a night with a full moon. But once the moon starts to wax or wane and you get to that crescent stage, you're looking at 0.1 lux and you're starting to get a lot of noise and poor image quality. Now, using this AI technique, we can actually start to bring out good quality images at that 0.1 lux. And then when you put this into an AI vision system where you want to detect something, what may not have been detected as something in the dark shadows is now being detected. So eliminating false negatives and false positives with this technique, we're getting this improved low light performance down to 0.1 lux. And a side benefit, an extra benefit from this technique, is being able to compress the images to a smaller size by as much as 3 times smaller. So has AI given cameras superpowers? Well, I think it certainly improved the performance by a large degree, or a big step change in capability of a regular camera and a type of camera that you're going to use in your cell phone or a digital camera or in security cameras. This AI technique is a big improvement, and I believe it puts it at about the same level as the human eye today, because we've kind of added that piece that was missing, which is that human vision system part that we have in our brain. So it kind of makes sense. Where's it going to go from now? Well, I believe we're going to see the fusion of other technologies, constant improvement in these techniques and image sensors as we go forward, and multispectral technologies, and the fusion of all of these and using AI. Certainly, I think cameras are heading towards having superpowers and being able to see way beyond what human perception can do. But that's an interesting future, and thanks for watching.